Okay, here we are in AMPL IDE, and we can now see what the napkin file. We've actually built a napkin file on the side, and what it shows is we've listed all the nodes. So we have a new and an old, and we have the 5 Ds and the 5 double Ds. And we have the all the arcs. So we have from the news we're buying for any amount, and that's $10, as we said before. The demand is 10, 50, 100, 80, and 10. We can send off, we can discard napkins any way we want, anytime we want, without any penalty. There's a loop, a circulation flow back from the old to the new, without any limit. And then we finally have these are the cleaning bills. So if we can send from dirty D1 to D2 express, so these express charges to the next day are all cost $2, and all the regular from D1 to D3, dirty D1 to D3 is 1, 2 to 4, 3 to 5, and then we ran out of time periods. So we now want to solve this problem. So we first open the network model. We say we want to use this as our model. We open up the napkin. We say we want to use this as our data. We say solve, and we say display flow. And this tells us exactly how the materials, how the napkins flow. This is the demand, so this is fixed. But then this tells us how to clean. So one effective way of displaying this is to take these values and put them back on the diagram. So we're going to do that, and we'll come back. Okay, so now we have the original formulation and we have the solution. I think we can now try to trace what's happening. So we'll start with the new, and we start by buying 10 units. That goes to D1. And so what happens at D1, those 10 units get used. We'll make those the DDs, and these the Ds. So this is 1, and this is 1. And from DD1, we go to D3. So we are going to, let's leave some room here for 2. And we're going to go to 3. So this one is going for regular cleaning. It's being sent to 3. And now let's see what's happening for day 2. From new to day 2, we buy 50. And those are the 50 that then get used on day 2. So we're going to buy new napkins to meet the demand for day 2. And we're going to send for regular cleaning those we bought on day 1. Now what happens on day 3 for a moment? On day 3, we're going to buy 40 units here. To meet the demand for 100, I believe. Well, we have 10 coming in here. We have 40 coming in here. That's only 50. And so these, let's see, from day 2, we're going to send all 50 to Express. So we're going to incur the penalty of the Express for meeting that 100 and keeping our so all of the ones that we bought are now going to be used on day 3, and we're keeping our need to purchase on day 3 to a minimum. So there was no way getting away with having to buy, well, I guess one might think you buy 40 and use those 10 for Express, but I didn't think that was the optimal. when I say didn't think that was the optimal, I didn't compute that to be the optimal. Okay, so now we have 100 are sitting at DD3, and interesting, those 80 of them go to D4. So 80 of them get sent via express to day 4, and 10 of them get sent to day 5. And so if we have 80, and what is the demand for day 4? Demand for day 4 is exactly 80. So we have no need to buy any new napkins for day 4. And nor for day 5. So they get used, the 80, and then I guess the 80 from D4 to DD4. What happens at from DD4? From DD4, we sent 80. Okay, from DD4 we have here the old, and we haven't been tracking what happens at the old. But from DD1 we don't send any, from DD2 we don't send any, from DD3 we send 10. So 10 go here, 10 get thrown out. I don't have a need for that many anymore. I need 80. I'll get those cleaned right away. I won't buy, and I will use those up. How many do we need on day 5? On day 5 we need 10. So those 10 came from the regular cleaning, and so the 80 from D4 goes straight out, and the 10 then go straight out there as well. So I needed to buy 100 napkins to make it through here, and then those 100 napkins flow back. And we have 100 as indicated here. So this is the solution that it suggests, and the optimal objective, I forget what it was. You can look back and see. You can solve it yourself. That's maybe the best thing. So that's gives us the solution.